Okay, let's work Pathways problem 3.17 from the textbook. It asks us to calculate each of three different things. Part A is the total number of ions present in 38.1 grams of SRF2. SRF2 is one of our ionic compounds. We call that what? Strontium fluoride. Right? Strontium fluoride. You can see from the periodic table, Sr strontium is in the group 2, so it has a +2 charge. Fluoride, of course, is -1. So they give us the formula here. We just need to figure out the total number of ions. Now we're given a grams, which is not a counting unit, it's a mass-based unit, right? So we need to convert into a counting unit. And again, most always, that means we're going to convert to moles. This problem will be no exception. Now, how do we convert to moles? Well, our desired units go in the numerator, undesirable in the denominator. Here, that's grams of the strontium fluoride, such that the units cancel the grams units, and we're left with moles. We simply need to know the mass of 1 mole of strontium fluoride to make this work. That's known as the molar mass, which in the case of strontium fluoride is 125.62. Do the calculation, and I get 0.3033 moles. And you may be asking, well, how did I get this number, 125.62? Went to the periodic table, and I saw that in 1 mole of this compound, I've got a mole of strontium atoms. I've also got 2 moles of the fluorine atoms. So you add up the parts, you get 125.62, which allows you to calculate the number of moles. Now we're not done yet, because the question asks us not for the number of moles of the compound, but the total number of ions present. Now remember, ions are simply charged particles, okay? So there must be some relationship between the number of moles of this compound, SRF2, and the number of moles of ions, total ions, okay? We're going to think about what in the world is that relationship. Now, think about this ionic compound. What ions are present? Well, a cation, positively charged ion, strontium. The anion, or the negatively charged ion, is the fluoride. I've got 1 strontium per formula unit and 2 fluorides per formula unit. So it turns out I've got 3 ions per formula unit, 3 moles of ions per 1 mole of SRF2. The mole units cancel. I just multiply this number that I got in the previous step by 3, and I get 0.9098 mole of ions, okay? That's the answer to part A. I like this problem. It's not necessarily completely standard, and it ups the difficulty a little bit, because here you had to compute ions rather than just moles of a substance. You had to understand what ions were and have the ability to figure out how many ions were present per formula unit of the substance. So it's a nice little problem, okay? Let's move on. Part B. All right, so what does B ask us about? Asks us about the mass in kilograms, so a specific mass unit of 3.58 mole of copper salt, specifically CuCl2.2 H2O. So we've got copper 2 chloride dihydrate here. Copper 2 chloride dihydrate. Okay. What is the mass in kilograms of 3.58 moles of this stuff? Well, again, To work these problems, we usually start with the number that we've got in the problem, okay? Now here, that's moles. That's our counting unit. What do we want? What's our desired information? It's the mass in kilograms. So we go back to mass here, okay? But again, as usual, at some point in the problem, we work our way through this counting unit of moles. It's very, very common to see that. Now, I want to go to mass in grams, and I want to get rid of moles of the compound. So that's kind of going to be my conversion factor that I'm going to work with. Now, to figure out what numbers to write here, I've got to figure out how much 1 mole of this compound weighs, or what its mass is. So again, I have to add all the parts. I add copper's number from the periodic table. I add 2 chlorines from the periodic table. I add 4 hydrogens from the periodic table and 2 oxygens from the periodic table. And if I add all those up, I get 170.48 grams per mole. Okay, so that becomes my formula weight, or my molar mass of this dihydrate compound. Okay, so I do the multiplication, and I find the question specifies I've got 610.33 grams of this copper salt. 610.33 grams of the copper salt is contained within 3.58 moles. So where do I go from here? Well, the answer specifies I answer in kilogram units, okay? So I really just have one more unit conversion that I need to carry out to make my answer jive. I move away from grams and move to kilograms. Now I know that 1 kilogram is 1,000, or 10 to the 3rd grams. So it looks like I have to divide by 1,000. And when I do, the decimal place moves 3 spots. I've got about 0.61 kilograms. Right, that's the answer to part B of this problem. How many kilograms are present? So again, that's a moles to mass conversion. So we need to be able to go both ways, right? Mass of substance into moles. But it's also necessary to go from moles back into mass. Part C asks us another mass unit. It's the milligrams of 2.88 times 10 to the 22nd. Formula units of what? Oh, it's another ionic compound. So another hydrate. All right, so we're given 2.88 times 10 to the 22nd formula units of bismuth nitrate pentahydrate, and we want to know how many milligrams does that correspond to. As usual, we begin by writing what we know. We have this many formula units. Remember, formula units for ionic compounds is kind of like synonymous with molecules. They're not quite the same thing, because the ionic compounds are organized in a crystalline lattice and don't necessarily exist as independent entities of ions and here water molecules bonded together. Okay, it's instead organized into a complicated 3-dimensional lattice, but nonetheless, these formula units work sort of like molecules. And as a result, I can use my Avogadro's number to convert to moles. Because 6.023 times 10 to the 23rd formula units corresponds to a mole of an ionic compound. And this allows me to quickly decide that I've got 0.04782 moles. of my bismuth nitrate pentahydrates. So I take that number, now that I've converted it to my mole counting units, figure out what in the world am I going to do with it. And again, this is that compound that we're dealing with here. Well, ultimately, I want a mass. So I'm going to have to go back to gram units, right? If I knew what the mass in grams of 1 mole of this substance of interest was, I could convert into grams. And of course, the mass of 1 mole of that substance is known as its molar mass, okay? So how are we going to figure that out? Well, we've got to add up all the parts. Okay? We've got to add up all the parts. And this one could be even a little bit more confusing, right? To figure out what all the parts are, because you've got lots of things going on here. For one, you've got a mole of bismuth in the total. Let's make a list of our parts that we have to add up, okay? Bismuth. What about nitrogen? How many copies? Hopefully you see there's 3. So 3 times nitrogen's number on the periodic table. What about the oxygen here? Well, I've got at least 9 oxygens from here in the multiplication 3 times 3. All right, now let's consider over here the water. Looks like I've got 10 hydrogen, and I've also got 5 additional oxygen. Okay, so I've got to add all of those parts together from the periodic table, and when I do, I find that I get 394.99 grams per mole of this substance. And when I do the multiplication to figure out how many grams, I get 18.88. Okay, so that many grams corresponds to this many formula units, which also corresponds to this many moles. All 3 of those numbers are measuring the same exact physical quantity of this material that's present, just in different units. Okay? Now I'm not quite done with this problem because I wanted my answer in milligrams, not grams. So I have one more conversion. For every 1 gram, there's of course 1,000 milligrams. The gram units cancel, and I'm propagating my milligrams units through. And in doing that, I need to move the decimal place 3 spots to the right. So 18.887 grams corresponds to 18,887 milligrams. This is problem 317. Being able to work this type of problem, again, I think is really absolutely crucial for your success with this material. It's also going to help you an awful lot as you move on in this class. So please spend the time to master it.